Welcome to the Emerging World track session. I think I'll just do a little bit of an introduction about what the session is all about, what our objectives are, and how we go about organizing this session. So this is something that is organized by myself. My name is Hadi from Singapore Management University, and my co-organizer is Lu Sing from ANU, Australian National University. But she couldn't be here today. She was around in the first couple of days, but she had other things to attend to. Now, the objective when we organize this track is really to make the so-called the World Wide Web truly worldwide, in the sense that, that people from all over the world would actually come to the conference. And I think that's something that we would like to increasingly have, and we would like to engage more and more communities. Sometimes they don't come maybe because it's not the right topics, maybe the community is just not engaged, or maybe they care about different areas of research. And I think we would like to reach out as much as possible. Now, in last year, 2024, in Singapore, we did this as a symposium, and this is done, in the workshop days, tutorial days. And I think one of the feedback that we got was that, hey, maybe there isn't enough interaction with the main conference. So therefore, this year we try to put it as one of the main conference sessions. So really, I think what we like to do with the session is to have some interaction, some discussions. It's going to be about topics that concern developing regions and emerging regions as well. It could also be about work that is currently being done that are of interest by people from these areas as well. So just to get you a sense, so we opened up a call for submissions. I think we received 10, and we accepted 7. And there was some condition to being able to submit, which is that at least the primary co-author should be someone from the list of ASEAN economically developing regions. And in this case, this is the distribution. We get 4 from Vietnam, 2 from China, and 1 from Iran. Now, of course, sometimes travel might be challenging for some of the participants. So in this case, we had 4 today. They're going to be presented orally, and they're going to be 3 that are presented by video because the authors couldn't come. They'll be at the very end of the session. Now, in addition to that, we would also like to have, in addition to talking about papers that are within the track, we also invited a couple of speakers that we think are going to be able to address some of the relevant issues and concerns of the emerging world. So now these are effectively the schedule for today. In fact, I think the first 2 are invited, and we're gonna start off very soon with the first speaker. So let me just invite Lakshmi to the stage as well. So when I invited Lakshmi, I was very pleasantly surprised that in 2010, he actually started the www for emerging regions. And I think the kind of the thread, I think, has gone from a long time ago. I think we are very, very happy that we tried to resurrect and we tried to kind of re-engage the emerging world again. So I think without further ado, let me invite Lakshmi from NYU, right? And let's welcome Lakshmi. We'll just help him to change up the slides.
Thank you very much, Hari, for a very kind introduction. This is going to be a very interesting talk of how we try to compete with 2 small companies. One is called Google, one is called Facebook. Trying to start an ad exchange in emerging markets. So we started a company called Gaius, which was global access to the internet for the underserved. And it's also the first name of Julius Caesar, Gaius Julius Caesar. And why it still did not work. We spent $500,000. We worked with some of the biggest telco players, Liquid Telecom, Orange Networks. We were part of the Facebook Accelerator. We were working with the Google Next Billion user team. And we realized in the process that even these giants are struggling to make money in emerging markets, even today, right? So we built an enormous amount of tech. We basically built like a full working operational system to build a decentralized ad exchange, a highly optimized web stack where you can load very high quality pages in very low bandwidth. We worked with the ISPs. We created a content curation platform back starting from 2019, 2020, where essentially the vision was, can you create a Kenyan web with Kenyan content, with Kenyan ads hosted in Kenya, and is a locally surviving ecosystem? And we failed. Okay. So why did we fail is a portion of the talk. And there is still possibility that we could resurrect. And I've written 10,000 papers in the space, gotten tenure, gotten full professorship, doing all this kind of stuff. But still deeper, one of the hardest challenges working in emerging markets is how do you actually build a sustainable business out of what you do today, right? And when I was talking to that gentleman from Google, he was mentioning that even today in India, it is hard to actually break even in one of the very large markets. Facebook still pays between $10 to $14 to acquire a single user to just download the Facebook app, under the hope that they'll make the $14 back. And here's a very funny calculation. If you click on a button in Bangladesh, the payout is 1/150th of a click in London. Okay. So we ran our ad exchange in Bangladesh running a singing competition, and we got more than 10,000 clicks. And my payout was $12, and my cloud bill was $14. I ran a tiny experiment out of a university called University of Cambridge with 200 users. Did something very similar with local users. And I got banned from Google Apps. And I had to fight with their ads team that we were actually doing something legitimate and not trying to create their spamming system. So why is it 1/150th when the purchasing power parity is barely 8 or 10? Part of the problem is they do not know who is willing to pay for what. They do not know how much money they will make, so they do not even know how to price. That's a big part of the problem. And the way I learned it was I actually hired 20 people, salespeople. Hey, will you pay 50 cents to just advertise your ad for 50 impressions, 100 impressions? Like local stores. We got like 10,000 users, even including the Maasai community in Kenya. And had excellent localized advertisements, still couldn't make money. The infrastructure was free, given to us by Liquid Telecom. We had like fantastic business deals. On paper, I could have gone and raised another 100 million and just said, I'm going to get you the next billion users, under the hope that we could raise money and we could make it big. But what you might realize is there are a lot of social network companies that have actually gone down that path and still don't make money. So truthful to our A/B tests, we had to pivot, and the company is still alive, is making money, but we are running an AI for recruitment. Right? I'm moving from academics to starting a bakery, right? As one person in the audience mentioned. So a brief introduction to this whole topic. That's the summary of the whole talk, okay? So we started with organizations, especially smaller communities, having a way to provide a unified online experience and creating, there were too many scattered tools. So what we built was Gaius, a decentralized, lightweight mobile web ecosystem where we can actually serve localized content with localized ads from a localized data center. So at a high level, these are some of the kind of things that we can actually do. These are fancy web pages that are creatable by people. Remember, this is 2019, 2020. So this is some agentic AI tools have become, which have actually made this a lot better, but this was done almost 5 years ago. And we essentially had a way where the ad exchange will create with the app, right? And we also had a way to add a marketplace where you could have offers, services, events. We could have communities with subscriptions, recommendations, your own communities, and you can actually create your own content and you can monetize content. So there's all this talk about user-generated content, how do you actually, and we also tried to even connect it with, cryptocurrencies for payments, local currencies for payments. We did all the payment infrastructure in each of these countries as well, right? So there was like a massive amount of engineering, and there was like a, Vickrey auction, all these kind of auction theories for how do you bid for ads, all those baked into the backend, right? And we actually formed specific communities around like Maasai communities, programming communities, coffee lover communities, specific for, we even worked with movie stars to create fan clubs. We worked with, cooking restaurants for dishes. We worked with running communities. So we essentially formed like localized communities that would actually engage with a certain set of users, right? And from a technical side, we had a content diffusion engine, we had a content summarization engine, we had a content curation engine, and an ad virtualization engine, and a content ad exchange where people could actually bid for ads, right? It was a C2C kind of play, B to C2C, if you want to put the business in there. And we worked in eight countries. We started stuff in Cambridge. We worked with a lot of engineering colleges to actually get local colleges to adopt it. And one of our really, really successful communities were kids looking for jobs. That was the pivot to actually making this into a recruitment agency, right? So these are some nice UI stuff. I don't want to bore you with various things in the interest of time. So these are specific customer examples. So this was actually a very interesting example. Orange Networks in Botswana, their primary partner was somebody called VUCA, which was run by a company called Browstone Enterprises. So we worked with VUCA to white label an app called VUCA Social. So we took our app and we are techie guys. We're not going to run a social networking company, right? That was not part of the agenda. So we actually white labeled, and we were even willing to create white label solutions. So VUCA Social, we tried to scale it up and try to get engagement. And one of the really tough things over there was getting the ad economics to pay out. This was a paid customer who paid us a decent amount of money with break-even economics. But they could not, at scale, where they had 750K users, they had SMS-based engagement for very simple payments, and that worked, but deeper content did not work. At least as of pre-COVID, slightly post-COVID times, 2020, 2021, there were a bunch of COVID-related issues also at that particular point. So the way we tried to make money was we tried to work with both ISPs and enterprises, and we had some notion of like a revenue share. You run this entire enterprise in a particular country. So our deal with Liquid Telecom, for example, was 50-50 revenue share. You run the entire Kenyan organization, we will actually do something. But when we actually hired people on the ground to make money, so many of these ISPs, right, they're a little bit lazy. Like, you do all the work, you can use my brand name. If you make money, then let's do a revenue share. That's the way it actually works. So even if you strike a deal with a local organization, You are responsible for building the sales marketing engine to actually show that it actually works if you're launching a completely new vertical. And Google and Facebook face this, Google and Meta face this community by community across a lot of countries. Right? So they are paying a lot of money to acquire these communities. And I wrote a digital communities report for Meta a few years ago, and still under the hope that it will lead to positive revenue. Okay. So just to give you, there were a whole bunch of platforms, hyper local platforms. Nextdoor has really taken off in the US and a bunch of non-emerging markets. But many of the ones that have scaled up to 100 million, 500 million users in emerging markets are yet to break into cash flow even territory. So, which is why we took a conscious decision to pull out at a particular point. There is a later talk I'm giving at 2:30 on a technical talk on something called MAML, Mobile App Markup Language. I can tell you why our markup language makes the web 10x faster than even Google AMP. So we created a new HTML spec where we removed something called JavaScript completely, and we got the same level of quality of a page. So if you're interested, come to my talk at 2:30. The last thing I wanted to say, so I told you about economic sustainability, that we could not break even money, right? The last thing I want to say is about environment sustainability. So one of the things that people don't realize is if you run a cell tower in Africa or India, 80% of the energy comes from diesel. Why? The power grid is not stable. So if you talk about creating data centers in many of these contexts, and you want to make them environmentally sustainable, we are very, very far. And if anybody says, I have bought carbon credits and so on, you're buying wind credits from somewhere else and you're using it in somewhere else to actually break even economics. But in reality, if you want to make locally, environmentally sustainable data centers to actually deliver these, we are still incredibly far. So let me pause there and take questions. So these are some of the lessons learned, and happy to share stories offline. Am I on time? Okay, cool. Thank you.
Started with a very large scale. Why didn't you start with one country, build the model, get it working, and then scale to the other countries?
This is a 2.5 to 3 year journey. And it was done in localized levels at various levels. And in each country, you face very interesting challenges. So for example, if you work in India, it is very hard to work with like the top telcos. In Kenya, you work with the Liquid Telecom, then you realize that you have to do everything on the ground. So you throw out a few darts, right? Some pick up, some don't pick up, right? So we burnt a lot of money, close to a few, maybe $100,000 on Google SEO campaigns and Facebook SEO campaigns. They don't work, right? The reason they don't work is very simple. People just download the app and delete it. Right? And we are paying a lot of money for every download. So it hits your download curve and it makes the VC happy. But in reality, nothing happens. So we did tailored experiments, and at some particular point, we pulled off and we went deeper. So when I say 2 million users, 8 countries, it is not 2 million users in one shot. It's 2 million users over 2.5 years, split across quarter by quarter, replanning, repositioning, repivoting. And historically, if you've heard of ACM Computing for Development, ACM Compass, Computing for Sustainable Societies, and so on, I'm actually the founder of those kind of conferences, and there's a ACM journal. So now I'm very happy to say that, 35, 40 people are doing this kind of work and have gotten tenure at top universities. So I was the first guinea pig to go for tenure, and now there's a big wave of community around it. So it's actually considered sexy to do this research. We were doing it at a time when it was considered not sexy. But to get back to your question, the point is we were very deeply pursuing country by country. And because we have done community networks, 10 years prior, we were able to tap into these and try out. But it was not like we did try siloed experiments and then pulled out. And we tried several variations. And the sad part is none of these really took off except recruitment.
So do you have legs on the ground? Like, are there people, do you work with people locally?
Yes. Otherwise, nothing happens. Absolutely nothing happens.
So is it infrastructural? Because you mentioned SMS works, but content doesn't.
No, you need people locally on the ground that you trust, that you are going to basically do the legwork to enable anything to happen. On the ground, there are some connectivity challenges, things are improving. There are infrastructure which is improving. The economics part still hasn't been properly figured out. In fact, right now, if we actually have to make this work, I think the struggle that many of the big organizations and the small startups are going through is trying to get the economics right. And in scenarios where there is a specific app for a very specific need, the economics has brilliantly worked. But if you try to generalize it as a general internet ecosystem, people still haven't figured out that unit economics. And one of the things I want to say is emerging market users are very smart and very careful how they want to spend their money. So if you truly show them value, it takes off. But if you try to show a general purpose thing, it still hasn't taken off. So, thank you. Any other questions?
Maybe just one last question. I think you've been working with this many communities as well. Do you have any perspective at all? Like, how do you engage them? Let's say as the web conference. Do you have any thoughts and ideas as to how do we draw them closer to, let's say, the conference?
So this is a great question. At ACM Dev and ACM Compass, we basically created a session where it was giving a booth to each of these organizations and literally having like a local marketplace where people just walk around talking. And we gave that like 2 to 3 hours. And that intermingling time enabled everybody to bring in a lot of connections. So that model actually works. Now, the only thing is, do not ask the communities to pay registration fees. And if it is local, and if you can bring them in with limited with zero registration fees, and you don't have to pay them. You don't have to pay them travel costs. You don't have to pay them hotel charges and so on. If you can actually just manage to give them like a particular slot, and don't expect them to stick around for the entire conference. They'll come for that day, and you have to maximize what you get out of it. So maybe like a workshop session, but you can actually do these
activities.
Yeah. So if you follow ACM Compass, which is happening in July in University of Toronto, they have like research impact sessions which are very similar, and that has become very popular. And it enables a bunch of like-minded people who are interested in a particular subtopic. So let's say you're interested in water, right? How do you do water conservation and so on? You could actually form a community around water conservation sensing, and you'll have like a whole bunch of NGOs who are also interested, and even some startup companies. And I've seen this around air pollution. It's become a big deal now. So yeah.
Right. Last time, too.
Thank you. Thank you very much. Yeah.
Maybe you can tell us Second talk is actually research paper. It's by a group from Brazil and will be presented by Eduardo, who will travel all the way here. And I think we look forward to listening to the talk. So.
Working? Can you guys hear me? Yeah. No. Hi, so I am Eduardo. I am the first author of this paper that I am presenting here at the poster session. And Heidi asked me to present this talk at the Emerging World session. And this is a network measurement paper titled Hidden Impact of Hardware Technologies on Throughput. And it was done by me and my colleagues at the Federal University of Rio Grande do Sul in Brazil. And also Theo Benson from Carnegie Mellon, which was supposed to come, but he couldn't attend this conference, so I am giving his talk in his place, and I hope it's as good as he would have done. So a bit of context first. The web has been shifting to a mobile first paradigm ever since 2015, more or less. And globally, at that time, the internet traffic that was coming from mobile phones amounted to around 35%, but ever since last year, it has grown up to about 68%. So bottom line is that the majority of people accessing the web are accessing from cell phones, right? And in the network measurement research community, the majority of papers are about cable connections and not wireless connections. And especially in developing regions and South America, there are no big network measurement papers published. But in recent years, we had the opportunity to work with one of the largest MNOs in Brazil, and we had access to their internal systems, and we got a data set from their wireless infrastructure. And that data set amounted to 7 million real user devices and 170 million measurements. And this paper is about a statistical analysis of this data set to identify the key factors in performance degradation just in wireless networks, right? So the last link of the network hops, of those network hops. So just to make it a bit more clear what I am talking about, this is a high-level overview of a wireless network, and it's basically the same everywhere. It has an MNO access core network, which is responsible for IP renting and security services. And I mean, since phones are constantly going in and out of the network, you need to manage those IP dynamically, right? Which is a bit more complex than in cable networks, where you just have a fixed IP for a host that usually lasts like 2 weeks. And in this case, we are talking about especially about the cell phones that belong to a coverage area and the tower that connects this wireless link to the cable network and the measurement servers that are inside the MNO access core network. And this network actually includes a gateway to the internet, right? That's how the phones connect to the rest of the internet. But since we are only interested in measuring the impact on the wireless link, we actually want to exclude the effect of the internet from the measurement that we are carrying, right? And we are doing that by placing the measurement servers inside the network. So each measurement session happens totally inside the MNO network and does not go through the internet, right? This is opposed to, for example, those famous sites like the speed test websites that everyone uses, right? You need to actually go to the internet to measure your speed, and that includes some randomness on what is the state of the internet at that time. And this architecture is supposed to fix that. So for the analysis, since we got such a big data set, right, like the Brazilian population is 200 million. So we actually got very many variables and many measurement points for each variable. And that amounted to we being able to do statistical analysis that we can only do on very large data sets. And for that, I used a matching pair technique, which is supposed to match each data point to a data point that's very similar on its feature set, except for the variable that we are interested in studying, right? So when you compute a correlation coefficient using those matching pairs, you discover that the effect that you get, it has a higher confidence interval compared to if you were not neutralizing the covariates that we call. And also I use the SHAP analysis, and I don't know if anyone here is familiar with SHAP analysis, but this is a very famous recent paper on machine learning interpretability. And it basically is a technique that is model agnostic to try to measure the impact of the feature set of any model and to quantify it. So you get each input variable effect on the output, and you can quantify what is this impact, right? So also about the data collection, this figure is just the mobile division of areas in Brazil. But what I wanted to point out here is that the measurements are randomly sampled according to the population, right? So areas with higher population, they get more random samples from the data set. And that is significant because we can generalize the results for the entire Brazilian population and not just a subset that could be biased. So to talk about network quality, the definition of a good internet connection is kind of arbitrary. So we use an industry standard to define what a good or bad connection is. We use thresholds from Tutela, which defines true classes, core, consistent quality, and excellent. Core consistent quality is common web cases such as photo sharing and messaging. And excellent are emerging use cases such as live video streaming, right, from recent years. And for Brazil specifically, before the pandemic, 46% of the connections could not reach the excellent consistent quality metrics. So in general, the wireless connection in Brazil was not good. But after the pandemic, this number decreased to 16%, which is generally considered a good result because since wireless connections are subjected to very signal problems everywhere in the world, you cannot really get to zero here. So 16% is actually a good result. And that comes from the increased digitalization that I think most of the world suffered after the pandemic, right? In Brazil, most digital and banking services moved to just online options. So having a stable connection is actually a necessity in the majority of the country right now. And we can get the average speed for each technology generation. I put 5G, 4G, and 3G instead of LTE and New Radio because these terms are more commonly understood. And we can see that they are very much lower than the theoretical limits for each technology. And for example, 5G is claimed to be up to 10 gigabits per second of download speed, and 4G is with carrier aggregation LTE networks are supposed to reach up to 500, but the average result is much lower than that. It's 23 for LTE, for example. And why is that? Is because many variables in the real environment are decreasing the performance that you usually do not are able to measure in a test environment, right? So the paper discusses that, and I just brought a couple of examples here because time is limited. The first one is base station load, which is the number of devices connected to a station at a certain period of time. And we can see that the downlink is much more affected than the uplink, which is expected because phones usually download much more data than they upload, right? And for the network that we are analyzing, the 10% most popular base stations, that is, the 10% base stations that are located in the most populated areas suffer a 20% performance degradation from this effect, right? And another variable are actually horizontal handovers. And handovers are the process that happen when you go out of the tower optimal range, then the MNO access core has to transfer your connection to other tower, right? And this process usually leads to a decrease in connection, and this decrease is actually very high. We measured 30% of decrease for 4G and 5G, which is a big decrease, right? But this phenomenon is not uniformly distributed across all instances of the data set, because it is concentrated in very specific periods of times and very specific base stations, right? So they usually only happen from 5 to 8 to 6 p.m., which is the commute from work to home in Brazil. And they usually happen on base station loads, which are located in not very populated areas. So in practical terms, this basically means that they are probably connected by roads. So there are base stations that are connected either in rural areas or roads that lead to rural areas. And these regions concentrate most of handovers in the data set, right? So handovers are not really that much of a problem in medium cities or big cities. And the shape analysis that I discussed earlier, it produces this graph, and there is a list of variables that the paper discusses. The examples that I showed, which are handover and number of devices, are actually high on this graph, and it is top to bottom, right? So like the top variables are the ones that the most impact the performance, and the bottom ones are that have minimal or zero impact. And so, concluding the talk, the performance in Brazil reached agreeable result in 95% of the cases, and the performance that we measured are much lower than the theoretical limits, and that can be explained by variables such as handover and base station load. And for a deeper analysis and comparisons to other studies, I mean, then I guess we'll have to read the paper or come to the poster session, because I did not have time to explain everything. And that's it. Thank you for listening. And if anyone has any questions.
So let's one question. So, when I have a bad cell phone connection, thank you. When I have a bad cell phone connection, I look for Wi-Fi. If I have a good cell phone connection, I don't bother. I wonder if that's going on here, like how many people have access to Wi-Fi in your data? And that would cause a distortion, because as the service gets better, people quit looking for Wi-Fi as much, so that it's understated the improvement. This is just a question.
We actually filtered in the data set instances where people were using Wi-Fi instead of mobile phones, right? So I agree with you that if people are at home, they're probably using Wi-Fi, or if they're at work, they're using the company's Wi-Fi. But in any other case, at least in Brazil, people are using generally 4G and 5G technology, because public Wi-Fi is not really that common, right? And I mean, this paper only discusses the impact of the mobile connections, but we actually took the care to exclude Wi-Fi connections. So yeah, for Wi-Fi cases, this discussion actually doesn't apply, because 5G especially has a different technology that they use for Wi-Fi. So it's not 5G Wi-Fi is not the same as 5G like in the wild. Yeah.
But that's not my point. My point is that with endogenous switching, you have a sample selection problem, which is to say, I might choose whether I'm using 5G or 4G, depending on how good it is, even if I have Wi-Fi. So people at home, as the 5G gets better, stop switching to Wi-Fi because they don't need to. This happens with my own children, so I know it happens at least once.
Yeah.
Though not in Brazil.
Yeah, I agree. But I think that these conclusions only apply, I guess, to situations that you cannot do that, right? Because if you can, then I mean, you are really not worried about how good the connection is. So I think the general conclusion is that you cannot generalize these results to any situation that you need to have a connection in Brazil, right? Just situations that you are only able to access wireless networks that are not Wi-Fi.
So is there a device effect? Meaning, does the quality of the phone matter at all in terms of, I mean, it could be 4G, it could be 5G, but
Yeah, there's definitely one of the, I didn't talk about the variable, but the device effect is actually very significant. Mostly because not only the network interface would be better in newer devices, but in Brazil, there are many devices that are not optimal, right? People don't usually buy high-end devices in Brazil. And as this data set includes everyone and not, for example, the speed test websites, they have a bias that people doing speed tests are generally people that are interested in the performance of their connections, right? But this data set actually comes from the app of the MNO that people use to pay their internet bill, right? So an old person that probably never cares about internet connection, doesn't understand anything, will still get their phone measured by speed, right? And this person usually has a very outdated device that they have for 5, 8 years. And this device probably has a very old interface, network interface, right? And this contributed to the device not being able to use the latest technologies available at the tower, and that contributed to the overall decrease in performance.
right? Let's thank Eduardo.
Thank you.
I think you'll have a poster session later today.
No, it's tomorrow.
It's tomorrow. So there we go. So I think we're gonna shift to the talks that I accepted in the emerging world session. I think the first talk is going to be given by Tim Casey. Okay, so maybe I'll ask this switch as well. It's a Halo pipeline based on data stack filtering in that program knowledge graphs.
Okay, good morning, everyone. Thank you for attending my presentation today. And my name is Tingting Wang, and I'm from Dalian University of Technology. It's my great honor to present the latest authors to give today's representations. And they are from Dalian University of Technology and RMT University. Okay, let's go to the first part, the background. And what are knowledge graphs and reasoning over temporal knowledge graphs? Temporal knowledge graphs is a powerful tool to model dynamic real-world data, and it has many snapshots at different time steps. So temporal knowledge graphs can depict the factor evolution with time. And in reality, the facts face the problems of incompleteness. So reasoning over temporal knowledge graphs can solve this problem and to predict the missing links within the temporal knowledge graphs in the future or of the current time steps. And here's an example of the entity prediction and the relation prediction. And the candidate who has the highest score will be the predict answer to the query. Owing to its expressive nature of modeling the dynamic data, it has achieved success in various applications, such as question answer system, recommendation system, and diagnal system, and so on. But in reality, facts tend to be outdated in temporal knowledge graphs, because if a fact whose duration date exceeds their expiration date, it will become an outdated fact. And table 1 lists some examples of facts in a temporal knowledge graphs, and their expiration date is on the right column. And Figure 2 is an example of depict how a fact to become outdated outdated with time passing. For example, Nikkei played for Manchester in 2009, and with time passing, this fact will become outdated and at the timestamp of 2012. And these outdated facts have negative impact, such as poor recommendation, biased AI models, and ethical issues. However, detect these outdated facts is not a very easy task because the challenge one is that it is hard to distinguish outdated facts from the normal ones because outdated facts in temporal knowledge graphs usually have the similar semantic information as the normal ones. And here are the example. When the temporal fact first appeared in the temporal knowledge graph, it is valid and appears as a normal ones. But with time passing, new facts are continuously added to the temporal knowledge graphs, and at a later time step, the original normal ones will become an outdated fact. And we can see from this example, we can clearly see that the 4 elements of outdated facts are mismatched but often relevant. They are same at the first column, that is the head entity, and the second column, the relation with the head entity and the tail entity. And the tail entities are different, but they are all where they play in their team member. So the temporal patterns of very outdated facts are diverse, so it is hard to distinguish outdated facts by using the traditional negative sample strategies. And challenge 2 is that it is hard to determine when historic facts become outdated. And figure 1 illustrates the temporal validity of facts within a temporal knowledge graph, and it is changing over time. The temporal validity of certain historic facts falls dramatically after exceeding a certain time interval, and various temporal facts experience different update patterns. So in the temporal knowledge graphs, various temporal facts have different trends to become outdated. For example, some facts update more frequently, such as the transferring of NBA players. And this type of historic facts are more easily to become outdated. And other facts which are seldom updated, and they have a low probability to become obsolete. Current methods mainly focus on construct logical rules or leverage external source or have the human-in-the-loop framework to detect artifacts in knowledge graphs. But they have some limitations. For example, when we construct logical rules to verify facts, it is hard to generalize because different knowledge graphs have distinct rules, and external sources often encompasses a small fractions of the entities and relations present in the knowledge graphs, and a human-in-the-loop framework mainly heavily rely on human involvements and labor-intensive. And the methods of temporal knowledge graph reasoning mainly focus on the positive importance of historic facts or model the periodical temporal patterns of historic facts. But they often ignore that outdated facts have negative importance of historical facts, and training on these outdated facts yield extra computational cost as well. So in our research, we aims at how to effectively detect and filter artifacts and eliminate a side impact on reasoning over temporal knowledge graphs. And in our research, we propose an efficient framework to filter artifacts, which is based on the half-life theory, and to cap the key features of artifacts in temporal knowledge graphs. We have a temporal fact mechanism or construct a fact-to-node graph to better learn the representations of the dynamic entities and the relations. And in our model, we can also currently predict the half-life of each fact in temporal knowledge graphs. And then we categorize the temporal knowledge graphs into two categories. They are active facts and inactive facts, which is based on their learnable representations in our model. And then we also design a time decay function, which is based on the predicted half-life by Hello, and in this function, we can well quantifies the temporal validity of facts with time to detect and filter all these facts. And besides, we also conduct a series temporal knowledge graphs reasoning experts to verify the negative impact of audit facts. And here is the first module of our framework, which is circled in red. And in our research, we found that the sharing head entity, which refers to the facts that have the same head entity, and they are very important in the process of the feature learning process. And then we construct a temporal factor attention mechanism, which can better capture the structural information of facts. And here is an example of the feature learning progress. And in our framework, the nodes are converted into the facts, and there are also the embedding of the entities relations and the time of the interval between the current time and the update time. So it can well capture the temporal information and structural information. And in the learning progress, the entity embedding is learned by the all facts that have the same head entity at all time steps, so it can well capture the connection between the facts that have sharing head entities. And the next part is the second module of our framework. It is the dynamic relation aware encoder module. And the object of this module is to acquire more expressive representations for temporal facts. And in this module, we can get more expressive representations, and it's better to categorize the activity of them. We found that the activity of the fact is not only related to its head entity, but also to its relation. So we construct a fact-to-node graph, and in this graph, if two facts have the same relation, the edge weight between them will increase to 1. So the fact-to-node graph can be further divided into a series of subgraphs, and GR1 represent the facts that hold the same relations. And in this feature learning progress, we use graph convolution networks to better learn the features of these facts. Okay. And then it is the audit fact filtering module. And then in this module, we can categorize facts into the two active and inactive facts. And here the model will predict the half-life of the active facts and inactive facts. And then at the last line, we constructed the time decay function. The input of it is t, I is the current time, and t half the half-life of time. And then we can compute the temporal validity of facts. When the temporal validity of facts is below the settled threshold, and it can be considered as an audited facts. And here is the optimization progress. We combine embedding loss, BC loss, and the reasoning loss together to obtain the final loss. And here's the experimental settings. We list 3 data sets in the real world, and they are all from integrated queries early warning system, which contains a large number of political events. And here is the evaluation matrix, mean, replicable rank, and HITs at K. Here's the result of the reasoning experiments. And we conduct experiments on the 3 widely used data sets and use 5 state-of-the-art reasoning tasks: CyGNet, Expert, RUGCN, and LogCL. And from the table, we can easily see that no matter which temporal knowledge graphs reasoning approaches we compare, filter outdated facts with our framework always improve the performance when predicting future events. And here is the sensitive analysis of theta and T half-life. And theta is a set threshold to control when historic facts become outdated. And the performance of temporal knowledge graphs reasoning decrease as the value of theta increases. And next, we also conduct application studies in our experiment, and we found that by without TGAT means the module removes the first framework removes the first module, and without GCN indicates remove the second module, and so on. And it's suggesting that temporal attention mechanism for learning dynamic features of entities has a large impact on detecting artifacts. And finally, to verify that training of artifacts yield extra computation cost, we conduct efficiency analysis of HALO. It is to record the average computation time of temporal knowledge reasoning tasks at the same setting. And we can observe from the table that with our homework, it's run faster than the temporal knowledge graphs method that are not filtering outdated facts. And finally is our conclusion and the future work. In the future, we will focus on expanding this framework to handle multimodal knowledge graphs. And that's all. Thank you.
That's right. We can please move on to the next talk.
Okay.
Thank you.
Okay, thank you.
So, the next talk is his recommendation. It's going to be presented by Dan Q from Vinh University, Vietnam.
Hi, everyone. So I will, on behalf of my team, present a paper with the topic with the title, Enhancing New Recommendation with Hierarchical LLM Prompting. And yeah, this is our presentation outline, and we will jump into the introduction very quick. Okay, so recommender systems are essential in our daily life, and a user could grab some recommendation when they are on an online platform. For example, social media or TikTok, YouTube, and personalization helps to improve user experience, delivers right content to right user, and then increasing the engagement between user and system. And therefore, somehow it could boost the performance for the platform revenues by subscription or click. And based on our observation, there are some obstacles for new recommendation system. For example, the massive number of news articles. So user user can't manually filter the articles they want to read, right? So because the number of the article. And another one is that user interest change rapidly. So they could their topic, their interest could be changed by the breaking news or a new training topic. Moreover, user interest also diversity. Different user care about different domains. And what we think that is a major point is that the article from different domain may semantically relate, but lack obvious word overlap in the title. For example, we have new one and new two, though are related, but based on the title, we see they are not. There's no overlap keyword or no overlap the words in the title. New 3 and new 4 are related, but we also see that the title, the keyword, the word in the title are not related. So if we use a conventional approach, it's really hard to get the right or the relevant recommend. Recent papers, they use LLMs to improve news recommendation. For example, they use LLMs as summarizer. They try to use LLMs as a summarizer to summarize all the history, all the title of the article the user read. They also try to use LLM to enrich the title. They believe that LLMs are equipped with the language understanding or reasoning ability or the word knowledge. So a lot of recent paper, for example, the paper published in 2024 at Web Conference. And what we observe in several experiments is that the LLM can explore the entity, some interest entity, given the title. For example, new 1 and new 2. New 1 and new 2, given the title that it advanced in AI revolutionized data processing, the new diagnostics tool enhanced early disease detection. So given the title, LLM can explore that title, the title related to artificial intelligence or machine learning or data analysis, medical imaging, or given the title of number 3 and number 4, Portuguese striker and Hollywood star Georgina. At first, if we see the title, it's very hard for us to know that those titles, those news are related. But when we ask LLM to generate, to explore the entity related to the title, given the title, we observe the output will be the Cristiano Ronaldo, and for the new number 4, that is Cristiano Ronaldo partner. So now if we put the entity into the title, it could somehow improve the performance of the new recommendation. But our proposed method, that is PNI-LLM, unlike traditional summarization that try to summarize the history, the title that user read, that approach try to compress, and by compress, we may overlook or ignore some detail or some small angles that user like or user may interest in. And in contrast, we try to explore the entity, what are interested, that may user interested in. And by using the explored entity, we believe that we could use that as the semantic spy or the core information to guide the LLM to generate an intriguing title. And by doing so, we could obtain the deeper semantic understanding. We could obtain a core contextual relevance, and we believe we could obtain high user appeal. And recent paper also proved that LLM excel at generating engaging language or enduring title. And our proposed method with every candidate, every news we follow up with. Every new we follow up with, we pass into the new enrichment module and follow up with the new encoder to generate the new embedding. For the user embedding, we obtain the representation of news for every news they read, and then we put the embedding into, we put the embedding into the attention layer to obtain the final representation for user embedding. And yeah, let's move into the main part, that is new enrichment model. And in this model, we have 3 steps. The first one is that generate, that is direct prompt. We try to generate a rich title. We do similar to the recent paper, trying to ask LM output the enriched title. In the second step, we ask LM to explore the fine-grained entity, for example, people, organization, or even. In the third step, we ask LM use the explored entity and guide LM to generate the final. Ask LM to generate the final integrating title. And that we believe, because we try to guide LM with the context, with the core spine, with a semantic spine. And we believe that using that way, we could generate concise information, and align with the original title. For the new encoder, we use entity we explored by LMs, the category, and the title. For the title, we use CNN model with the globe embedding to generate contextual information from title. It's experiment. We try to evaluate our model, our method with my data set, and evaluate. We use a evaluation metric that is AUC, ADCC, and MRR. This is the my data set. We use with 2 versions of my data set. And we compare our model with several baseline. And based on the table, we observe that our model with very simple news encoder could achieve very good results. You could notice that the several baseline models, the gap between several baseline models are very small, but the gap between our and the most recent paper on news recommendation are big enough. And for the large, we observed that we achieved the second best result. We think that maybe for the new encoder, we use a globe embedding instead of some pre-trained language model, so we reached the second best one. We also investigate the effect of different prompt strategy, and recent paper they try to put the topic or some relevant information to the prompt to generate integrating title, and yeah, so we could see that based on the figure, our hierarchical prompting strategy generate output the best performance, the highest performance. And we also investigate what is the best model to generate the integrating title. So we investigate Gemini, Llama 3, and GPT-4o Mini. And based on our observation, that is Gemini 1.0 Pro will output the best performance. And we also, as I mentioned earlier, so we use CNN as an encoder of the title, and now we train the globe embedding and BERT. We change the globe embedding to the BERT model. Now we use this BERT model to replace a submodule in the new encoder. And we observe that with those trains, our model with this BERT reach the highest performance. We also notice that our generated model could replace, could be the output, could be the input for any baseline model. For example, NRMS, MANL, or LSTUR. So we could use our generated title to other baseline model. And so if we use that, we observe that the baseline model significantly improved, similar to the entity. And with our enriched or exploited entity, we have a better performance. So this is the conclusion. So we think that with the instead of doing summarizing, we try to explore. It means that we disperse instead of compress. So we try to find some interesting point. Try to another point that is, if we're doing so, we could tackling the data sparsity. We put, because we could we could embed some entity into the title. So it means that we could somehow we could make the title overlap, and that could have the recommendation performance better. And by guiding LM by the entity, we believe that we could generate the correct title that align to the original one. Yeah, that is our presentation. Thank you for the attention.
Question? Just one question.
Then can I ask a question? Since you are conducting an in-context learning, then how can you deal with the hallucination issue?
The most the major point for hallucination, I think, that is explore the entity, right? So we have another step in the exploration. Whenever we obtain the entities generated by LMs, we will put into the Wikipedia to verify. So United States and US so will be the same entity. So we try to put into the API of Wikipedia to verify whether it's the correct entity or not.
Wise choice. Thank you.
Thank you.
So we
When you
are
open
gonna
this
work on
link,
next
you will
talk.
be going to the slide.
The next talk is actually by a group
What's the
from
link for?
Vietnam
The slide,
National
my
University.
presentation. The slide.
But,
Yeah,
talking about DK today, so it's going to be presented by Roxy. It's one of their colleagues from Planning here. He's going to talk about the co-attended infusion of structural knowledge into language models towards legal textual inference. Just give us a minute to get the thing on the screen.
Do not leave.
Okay.
Open present with us. The note. No. Okay, 1 second, 1 second. It's a little bit weird. It's okay. Hi everyone, I am he, and I'm not one of the author of the paper. So because they are unable to get the visa to travel to here to present the paper, so I will present the paper on their behalf. Okay, let's begin with the problem we are working on, the legal textual inference. For example, given a premise, which is the legal article about the owner of the land or immovable, and we want to determine, and we also have the hypothesis here. For example, Alice grow her seeds on the land owned by Bob. If the seed grow to become a seedling, the ownership of the seedling belong to Bob. Is quite obvious to us right now, right? And in this problem, we want to determine whether the premise support the statement. For example, we want to give the output of this hypothesis is true. And because in this legal domain is relating to a complex relation between entity and concept. So rather than present on the text only, we believe that it is better to present the hypothesis or premise in a graph. For example, Alice go seed on land or by Bob, and the seed becomes seedling belong to Bob. This is the graph example we want to introduce. And the current problem with the pre-gen language model. When I talk about pre-gen language model, I prefer to some transformer model like BERT or Robot 8 or something like that, but not the large language model like ChatGPT. And the current problem with the pre-gen language model is they solely based on the semantic information. What does it mean? The semantic information is the information in this one we encode into a vector space, and we didn't incorporate it into a structure. So we call it in solely based on the semantic information. And because in legal domain, we have the limited label data, because the label force to annotate the data in this domain is very, very high, very costly. So this is the current problem of the pre-gen language model. And in this paper, we introduce the AIKLR to improve the inference quality of pre-gen language model. This allows the model to learn from both structure and semantic patterns without scaling up the model size in training data. And we experiment on 2 benchmarks, so significant improve on the data set we experiment. Let's jump into the architecture of our model. In this model, we incorporate 2 layers of presentation. In the left-hand side is the semantic presentation. For this text, we will incorporate into a pre-gen language model like BERT, and we get the vector presentation for this, and we call this is the semantic presentation. And we also feed this input into an AMR parser and to generate a graph. And then we also incorporate this graph into a pre-gen language model, another one, to get the vector space, the vector. And then we incorporate them together, using an attention layer, and then fit into a classification layer at the end to classify it whether it's a yes or no statement. And for the structural presentation, we, as I tell you before, we use the AMR parser. This is the abstract meaning presentation parser from previous work. And this will generate a graph in directed graph, with the node is the concept and the edge is the relation between concepts. And we believe that the encoded information will not lose any adjacent information between the entity and concepts. And next, this is the attention layer we want to introduce. We propose in this paper. It will incorporate 2 input, the text input, which means the semantic information, and AMR input, which means the structure information, and into the to take the cross attention between them. And we also apply residual connection to improve the training and learning. And at the end, we use cross entropy plots for the classification. Okay, we experiment the model with 2 data sets COLI 2023 and COLI 2024. The input is the statement and the articles, and the output is yes, no. This is basically a classification problem. And we use the metric accuracies. This is because these two datasets is from a competition in a competition. So we will follow them to use this metric. And this is the result. And first thing I want to notice is the size of the model. This is the two hours model. We only use around 300 million parameters. This is comparable to the baseline we present here, with around 100 million parameters. But when it compared to the large language model, it is much smaller than this model. This is 100 billion, and this is 1.7 trillion. And we can say that compared to our baseline, we outperform them in both of the two datasets. And when it comes to the large language model, we also achieve the comparable result in the COLI 2024. And we believe that because of incorporating the structure into our network, it would benefit the model to identify the relation between the concept and the entity, so it can classify better. And this is the comparison between our model with the teams that participate the competitions on the COLI 2024 datasets. And we can see that we can obtain result with the third team in the run, but we use a much smaller model compared to them. And in conclusion, we introduced this new model to improve the inference quality, allow the model to learn both from structure and semantic patterns without scaling up the model size in training data. And result on two benchmarks show that significant performance gains in this domain and achieving comparative with the number of recent LMs. And in the future work, we will focus on extending this model on other tasks in legal NLP, because in legal NLP, we have a lot of tasks, and we believe that the structure orientation would be beneficial in any model in this domain. So this is the end of the presentation. So thank you for your listening.
Will you take questions?
Yeah, if I am able to answer it, I will answer directly. If I cannot answer, I will direct it to the author of the paper. Sorry.
Just convey, firstly, thank you for presenting. And firstly, thank you for presenting on behalf of the authors. You did a fantastic job. And the results are also very surprising. So convey my best to the authors.
Yeah, thank you so much.
Thank you.
Thank you, everyone.
So we'll invite the next speaker. We're going to talk about approval data, the multi-model, emotion recognition.
Okay, good morning, everyone. It's my honor to present our work here. The title is EmoMeta, a multimodal dataset for fine-grained emotion classification in Chinese metaphors. My name is Jing Ren, and I'm currently a PhD candidate in the School of Computing Technologies at RMIT University. Feel free to contact if you have any questions via jingdoren@ieee.org. Okay, so my presentation will follow this agenda. Firstly, I will briefly introduce some background information about our paper and the motivation, and then I will show you how the dataset is constructed, some fine-grained emotion categories, and the scheme of how we annotate our dataset. And then I will give you a brief analysis of our dataset. Finally, I will summarize our contributions and discuss some future works. Okay, so it's common that metaphors have been playing an important role in expressing emotions in our daily lives, in our daily conversations, and metaphors are frequently appearing in not only text but also in images, like in these three figures. And however, current studies they mainly focus on single modality, mostly focusing on text, and they are predominantly in to analyze English metaphors. So this definitely leaves a significant gap in multimodal Chinese metaphor-based fine-grained emotion classification. So to bridge this gap, we construct a new data set we named EmoMeta that specifically focusing on the multimodal Chinese metaphors. As for the data sources, there are three main sources. The first is a previously established data set, which is also our prior work. And the second data set is a publicly available data set that all of us can download from this website. And the last source is that we meticulously search across different prominent search engines, including Baidu and Bing, and I think both of them are widely popular and possess many extensive resources of images. And as for the data process, we validate the image uniqueness using MD5 encoding, and we extract the text from the images using PADO OCR model. Also, we definitely do some manual corrections to ensure the accuracy. Yeah, and here we classify our the emotions of our data into 10 classes, including joy, love, trust, fear, sadness, disgust, anger, surprise, anticipation, and neutral. Actually, originally, Ekman proposed the first a set of 6 basic emotions comprising both positive and negative emotions. And later, Plachik expanded based on his model by introducing trust and anticipation. However, we think that these eight classes of emotions cannot fully capture the richness of our metaphors. So we incorporate love and neutral into the categories. And as for our annotation here, we recruited native Chinese speaking researchers who has expertise in metaphors, and we divided them into 3 groups. The first two groups, they labeled the images independently, and the third group just resolved some disagreements through re-evaluation and majority vote if necessary. Here, this is just an example of how we label the picture. We can see that the tab here, if we want to, for example, if we want to, if the image is a metaphor, if we want to, for example, time is money. If we say time is money, we want to use the value of money to describe how precious is time. So here we say that time is money. Money is target domain and the money is source domain, and the time is target domain. So here, as shown in this figure, the source domain is hand, and we use hand to describe the word, and the word is target domain. And here the text shows praising civilization, speaking civilized words, doing civilized things, and being civilized people. And actually, finally, we think that we achieve a stable agreement with kappa scores of 0.68 for metaphor identification and lower but acceptable kappa scores for also source domain, target domain, and emotion categories. Okay, here is just a brief analysis of our data set. As we can see in this figure, our data set is composed of over 5,000 of images and its corresponding labels. And in this data set, nearly 87% of the images are public service advertisements, and the remaining are commercial advertisements. Here we can see that fear and anticipation are the most common emotions in our data set. And as for the public service advertisements, the prevalence of fear and anticipation emotions are most notable because we aim to the stakeholders want to create fear as a warning for the audience. And for the commercial advertisement, it shows a higher proportion of surprise instead of some negative emotions like fear, sadness, disgust, and anger. They appear less frequently in commercial advertisements. Okay. And here we summarize the contributions of our work. Here we propose a pioneer in multimodal metaphorical fine-grained emotion dataset in Chinese, and the whole dataset are annotated manually for metaphoric presence. Metaphoric presence, source domain, target domain, and fine-grained emotion category to address the lack of this such kind of data set in the research area to promote future works. And for our future works, we want to conduct some research on emotional causal analysis of multimodal Chinese metaphors. And also we'd like to test some baseline models on our data set to verify the effectiveness of our data set. And here just a list, a brief reference list for the content I just mentioned. And thank you, that's all. And if you have any questions, or if you like to explore more resources about this dataset, you can download it from this website. We will this dataset will be publicly available after the paper is published, and just feel free to reach out if you have any questions or would like to collaborate. Thank you. Thanks for your time and thanks for listening.
So, do you explain what makes it unique to Chinese metaphor, like as opposed to, let's say, other languages and so on? Is it because just the
Yes, metaphors are actually existing in different languages, and I think different languages have different kind of metaphors because of maybe culture difference, and also there are different we have different speaking styles. So actually here most currently research are focusing on English metaphors in English, language of English, but research on Chinese metaphors is still lacking. So here we just want to construct such kind of data set, including Chinese metaphors for researchers to do some research in emotion classification, emotion recognition, or even emotion prediction. Yes.
Did you test existing emotion recognition classifiers? It doesn't work so well on metaphors?
Yes, I think metaphors can be evaluated from different in different models, not only just some maybe models designed only for emotion classification. I think maybe some large language models can be used to test whether whether they work in emotion recognition, in metaphors, in different languages. Yes.
Okay, let's thank the speaker.
Thank you. Thank you.
Right. So we've come to the end of the oral presentation part. There are actually still 3 papers, so they're going to be presented by video. They're short videos within 3 to 5 minutes long. So I think I will present. Yeah, so if you like to stay around, which I hope you do, we're just gonna play the 3 videos one after another for the next 10 minutes or so.
Mute here.
And would like to present our paper, Cytokine Citation in Rich Dataset and Heterogeneous Graph-Based Model for Scientific Article Summarization. Nowadays, the number of scientific documents have grown significantly, highlighting the need for more effective summarization model to enhance summary quality. Some researchers have explored incorporating citation into model input. However, limited citation in this dataset hinder large-scale adoption. So in this paper, we would like to introduce Cytokine, a large-scale citation in this dataset, and we would like to propose a heterogeneous graph-based summarization model that integrates both internal and external information. Automatic summarization of scientific documents have been studied for many years with both to approach yield internal and external information. And a well-known approach for scientific summarization is to represent relations using graph structure. I will talk about the process of constructing the Cytokine dataset. Firstly, we select a subset of the kind chaining set to remove noise and reduce chaining set size. We use LDA to cluster chaining document into topic and select the top document with the highest probability for each topic. In the next phase, we just draw and extract citation information for each input document with the process. So we also would like to propose a model with you both document and citation to generate a comprehensive summary. In the first phase, we present an input document D as a heterogeneous graph and we present a set of citations and integrate them to heterogeneous graph D by a dummy node or name citation hub. And in the next phase, we use graph attention network to update representation after each interaction. And we also calculate the contractive plot to support representation learning and fit formula. In the final phase, we concatenate the representation from EDU and its corresponding sentence and section, and then fit this representation into NLP layer to estimate an importance score for EDU. In the chaining process, we also calculate the summary loss and final loss in this phase. So as a result, compared to relevant dataset, Cytokine is the last dataset. Our model also outperform other on all the evaluation score when evaluate in science kind. When citations are removed from model, the performance of most model decrease, so that citation is valuable information. Application experience also show that the proposed model in as the growth component in the model play important role. So in this paper, we introduce hierarchy, a large-scale citation extension archive dataset. We also propose a heterogeneous graph model that integrates internal and external information. As the experience results show that our model outperform other related model. So there are some reference we use in the paper. Thank you. User bundle and use the item historical interaction along with bundle item affiliation as well as to predict the user bundle interaction by predict the user bundle probabilities. To be familiar with this program, I would like to briefly introduce some work and point out that with common weakness, exists the bundle management method applied web-based technique under the magic factorization framework such as Procedure and Register with achieve high result in bubble setting. Furthermore, code focusing on recommending code bundle to user by leveraging procedure micro and curriculum strategies. Coding perform well in the code scenario, but this formation models are fully updated in space. Really, the key weakness of the magic factorization framework in code setting. To tackle this problem, our team introduced this code is based on distribution space and efficient model to directly generate a probabilistic bundle user. This code apply descendable cell retention technique to enhance user independence to better guide the diffusion process. Additionally, we apply a multi-purpose context level library blocks to firstly inject the user preference at item level to the generative process. Secondly, it helps the model to avoid bias when using the positive model as the reconstruct method. To study the effectiveness of this goal, we set up experiment to verify its performance in WhatsApp setting on real-world dataset. Then we use the artificial and new than using recall and anecdotal to evaluate its performance along with other baseline data. as shown in table 1, this code will be up multiple baseline network, but a very large money when compared to the traditional cold start item management method. This code still consistently achieves so bad performance, as shown in figure 2 compared to COVID cold start bundle recommendation. Variant method perform better by 80% on view. The very large graph can be seen on the application at Jusu. Furthermore, I also kind of experience the verify the everything in this each component this goal as showing figure 2 from the average study. You can see that each component has a positive impact on this goal. Furthermore, to study the stability of disco, I compare the evaluation results of disco and the second best baseline analytically across different training epochs, where COVID achieved its improvement when the triple loss grow up, while disco reached its highest result when dislock control persisted. Finally, I would like to thank everyone for paying attention. For further information, please reach out to me at the email displayed on the screen. Thank you. One more.
Hello, I am Sinet Family from Shiraz University presenting. I'm fluent on literature and aim to improve methods for identifying peer preparedness. We will cover the importance of influential nodes CSIR methods as a baseline and the limitations of causal decomposition. However, introduce the method and this improve accuracy and efficiency. Influential nodes are vital for controlling the use spread of advertising and managing information for social contexts. Identifying them has significant real-world impact. The SIR model simulated spread, but is computational distance with all large networks. We aim to use a more efficient graph structural features for identifying influence. Causal decomposition identifies network networks of its structure with densely connected subgroups and loops. Differentiation among nodes and cells is multiple worldwide, a global spectrum, global spectrum, and unity using a middle solution but can have higher computational complexity for recurring parameters. Parameters to improve R&D. Other related like mentality, visiting, and different stuff also exist. Often incorporating intent and local cross-network but may still involve manual parameter adjustment. They introduce self-influence, neighborhood influence, feature sort, intent, and causal analysis. Leading to a new metric, muscle accuracy model, with better accuracy, resolution, and linear complexity. We evaluated our method and the data set of 7 diverse complex networks ranging in size from 0, 100 to 10,000 of nodes with various structural properties. Our proposed method MSM and used in the Bradford demonstrates the highest accuracy in identifying influential nodes across the network when compared with other methods, and using sample style as well as studying their following. The proposed method also is high resolution distinguishing not influence delivered by mortality index, after bumping the economy as 6 of 7, Next one. Computational efficiency is crucial for one method. Our method with stable and partial with linear comprehension makes it more scalable than the required example, but typical section really has to be enhanced. Now, thank you for your attention. Now, I will have any questions you may have regarding research and fun.
All right. So, come to the end. So thank you for faithfully staying to the end. So, the last few, of course, it's not ideal that it is done by video, but I think taking into account the whole objective and track of getting more and more people from the emerging regions involved, it's not always convenient for them to travel, not always easy. So we kind of try to go within conflict. The papers that you see today, they're going to be part of the proceedings. They're going to be added after the conference. So I think with that, I think thanks to all of you for talking, for listening, and hope to have more interactions the conference as well. Thank you. And thank you for attending. No problem. Thank you. Thanks for your support.